In this lecture we'll see how to reduce the force couple system into single force and a couple. But before this we have already known that if the force is shifted from one position A to another position B, then we have a rule, and the rule says that the magnitude and the direction of the force remains unchanged. And second thing is that whenever we shift the force, additional moment is produced about new position at B, and which can be calculated as moment of force about point B equal to B any end point of force, that is BA cross F bar. So using this method we can reduce the complicated force system into a very simple force system, a single force system. So suppose we have a force passing through point A, and this point is B point where we want to shift the force. So right now we have a force F passing through point A. Now we want to shift this force from point A to point B. So according to the rule number 1, the magnitude and direction of force remains unchanged. So you have to copy down the same force at the new position, so the force is shifted, but the force will not shifted. In addition to that, the additional moment is produced about the new position. So the one moment vector is generated, which is the moment of force about point B, and is calculated as BA cross F bar, and this is passing through the point B. So single arrow I am using for force and double arrow I am using for moment, just to clearly distinguish between the force vector and the moment vector. So we'll use this demonstration to replace the number of forces in this system to a single force. So I have a one force acting at A, and I want to shift this force to position B. So I can shift this using this concept, and if I shift this, I will get one same force F bar acting here, and the moment of the force F by B, F about B. So this pair we will obtain here. Suppose we have one more force at point C, which is equals to T bar. So this force can also be shifted here. So whenever the force is shifted, we have the one force and one couple is generated about the point B. And suppose we have one more force here, that equals to Q passing through D, then that can also be shifted to the position D using the equation, using the one force and one moment above Q about point B. So in this fashion we have three forces, F bar, T bar, Q bar, which are acting at point A, C, D, can be effectively shifted to point B. So when we shift all the three forces, we have force F bar, we have force T bar, we have force Q bar, plus one additional moment due to F bar, one additional moment due to T bar, one additional moment due to Q bar. Now what happened here is that this force Q bar, F bar and T bar, all of them are passing through point B, so that forms a concurrent force system, and concurrent force system resultant is given by a simple vector addition of all the three forces, that is resultant R bar is equal to F bar plus Q bar plus T bar, and that will pass through the point B as shown like this. Whereas similarly we can add the moment also. So if we add all moments, that is the sum of moment of all forces about point B, is the moment due to this force B, the moment due to this force, it should be actually Q here, please read this as Q, and moment of force T about B. So this is the moment of force B, that is first quantity. This one should be equals to moment of Q about B and plus moment of T about B. So there is a correction here, it should be equals to Q and this point should be equals to T. We make our system more complicated, that is in addition to three forces, suppose we have two more couple acting, one is C1 and one is C2. How I am showing it does not matter, this is just a vector representation. So in addition to the force system, if we have additionally two couples C1 and C2, we can shift this couple to the point B without any modification, because the couple is the free vector, so no modification is required to shift it. So we can shift these two couple as it is through the passing through the point B, and once I shift this force, then I have a modification in this diagram, but there is no additional force generated, so there is no change in the calculation of R bar. But as far as my moment equation is considered, I have to add two terms, one is C1 and one is C2. So using these two equations, any complicated system we can reduce to one force and one couple. So you remember only two steps. The step number one is to find out resultant, which is the summation of all forces. Step number two is the sum of moment of all forces about the point B, and then we can reduce this type of system into one force and one couple. Let's take one example here based on the previous theory. So we want to replace the following force couple system into single force and couple at point D. We can shift this to any point D, whether it is at origin or somewhere else. So we have one force is P bar passing through point A, 4, 1, 2, and the value of P bar is 2i plus 4j minus 6k. Another force is Q bar passing through point B, coordinate is 3, 1, 0, and Q bar is minus 3i plus 2j plus 4k. Then third force is T bar passing through point C, 1, minus 3, 2, and the value of T bar is minus 6i plus 4j plus 2k. In addition to this, I have two couple, one is C1 and one is C2 bar, where C1 bar is 10i plus 12j minus 6k and C2 bar is minus 12i minus 4j minus 8k. So I will use a two step. One is the sum of all forces and second is the moment of all forces about point D. So resultant will be simply R bar equal to P bar plus Q bar plus T bar, which is just you have to substitute the value of P bar, Q bar, T bar. Then you collect the terms of I, J, K, 2, minus 3, minus 6, 4, 2, 4, 4, 2, 4, minus 6, plus 4 and plus 2. And now you will get a result of resultant R bar. So R bar equal to minus 7i plus 10j plus 0k. So all these forces will be replaced by one single force whose value is minus 7i plus 10j plus 0k. Now what we'll do, we'll find out the moment of all these forces about the point D. The sum of moment of all forces and couple about point D can be written as, we have to use these equations and you have to write down one by one. So moment of force P about D, moment of force Q about D, moment of force T about D. This one is already a couple. This one is already a couple. So we have 5 terms in this equation. These 3 terms you have to obtain by using a determinant, and then we'll add the value of C1 and C2. So this equation can further be written as moment of P about D can be written as D, and this force is passing through, P bar is passing through A. So this is dA cross P bar. Moment of Q about D, so Q is passing through B, so this is dB cross Q bar, and then T bar is passing through C, so this is dC cross T bar plus 2 couple as it is C1 plus C2. Now we don't know the vector dA bar, dB bar and dC bar, so we'll first find out the 3 vectors, that is dA bar, dB bar and dC bar. dA bar is given by A coordinate of A minus coordinate of D. So coordinate of A is 4 minus 2 2y, 1 minus 2 minus j, 2 minus 2 0k. Second, we can find out dB bar. So dB bar will be equals to B minus D. So 3 minus 2 is I, 1 minus 2 is minus j, 0 minus 2 minus 2k. And then we'll find out dC bar, which is equals to C minus D, 1 minus 2 minus I, then minus 3 minus 2 minus 5j, then 2 minus 2 is 0k. And now we'll put all this value in this equation. So what we get is, first of all we have to write down dA bar. So this one is dA bar is 2 minus 1 and 0, and P bar, so P bar is 2 4 minus 6, 2 4 minus 6. Second, we'll write down this equation. So this is dB bar, so dB bar is 1 minus 1 minus 2, 1 minus 1 minus 2, and this is Q bar is minus 3, then 2, then 4. Then we'll write one more term, that equals to dC bar cross T. So dC bar is minus 1 minus 5 0, minus 1 minus 5 0, and this is T bar, so T bar is minus 6 4 2, minus 6 4 2, and plus C1 plus C2 as it is. Now we'll solve all these determinant. To solve this equation, first of all I will solve for I. So minus 1 minus 6 is plus 6, 0 into 4 is 0, minus 1 into 4 is minus 4, 2 into minus 4, so that should be equals to plus 4, then minus 5 into 10 is minus 10, second term is 0. Then we'll calculate for j, 2 minus 6 is minus 12, 2 into 0 is 0, 1 into 4 is 4, minus 3 and minus 2 is plus 6, and then another one minus 6. Then finally we have minus 2 and 1 is 0, and then we'll calculate for k. So 2 into 4 is 8, minus 1 into minus 2, minus minus is plus 2, 1 into 2, so this is 2, minus minus is plus, and one more minus is minus 3, minus 4, and this one is minus 30, and then c1 plus c2. So we'd add all I, j, k, and what we get is the addition of this one is minus 4i plus 16j minus 25k, and then we'll write the value of c1 bar. So value of c1 bar is 10i plus 12j, that is this vector. Then we'll write the c2 bar, which is equal to this vector. Finally we add all these terms, and what we get is our final result. So our final result is minus 6i plus 24j minus 39k. So we left with one force that equals to minus 7i plus 10j plus 0k, and one sum of moment about the force about point D, minus 6i plus 24j minus 39k. I will take one more problem based on this one. I want to reduce the set of forces into single force acting at origin. So this time we have a not point D, but we want to pass to the point O, that is origin. We have given three forces. Their magnitude is given, their end point and their start point and end points are given. So first of all we'll try to find out the vector F bar. So F bar will going to pass from point A to B, and therefore the definition of F bar will be F into AB bar upon mod of AB bar, which can be equals to F equals to 140 AB bar. So we can write AB bar as B minus A, so that will be equals to 2i minus 6j plus 3k, and mod of this is under root of 2 square plus 6 square plus 3 square. Minus sign does not matter here. If you solve this one, we'll get 140 divided by 7, this one is totally 7, and minus 2i minus 6j plus 3k. Finally we obtain the force F bar, and force F bar will be equals to 40i minus 120j plus 60k. So this is 140 divided by 7 is 20, so 20 is get multiplied, and we can write the force vector. Now the same procedure will follow for P bar. So P is directed from C to D, so force is directed from C to D, so we can continue the same procedure, and finally we get the value of P bar equals to, so P bar is equal to P into CD bar upon mod of CD bar. Value of P is 260. CD you can write as D minus C, then you take a denominator of this one. So 260 divided by 13 is the value of this root. So this one equal to 20. So multiply 20, you will get this value P bar equal to this one. Similarly, we will proceed for the third case, that is a T bar, and again we have to repeat the same procedure. So go on putting the values, and finally we obtain the value of T bar equals to 180i minus 180j plus 90k. Please check this procedure. Now the resultant force can be obtained by just addition of F bar P. So you can add all this quantity, you will get 460i, this will be equals to minus 240j, and this equals to 230k. Now next step is to find the sum of moment of all forces about origin. So sum of moment is caused by three forces. There is no couple here, so there is no term of C1 and C2 here. So we'll break up this term. So we can write this first term is equals to we want to shift at origin. So therefore OA cross F bar, second term is OC cross P bar, and third term is OE cross T bar. Now OA, OC, OE, they are joining from origin, so we can directly write down the coordinate of point A, but I will show you how to write down OA. So OA is nothing but a coordinate of A, OC is nothing but coordinate of C, and E is nothing but a coordinate, OE is nothing but a coordinate of E. So we'll just substitute here, and if you substitute we'll get three determinants. This one is IJK, this is OA is 3, 7, minus 1. This one is F bar 40 minus 120, 60. Then the second determinant we'll put for OC bar, which is equal to minus 6, 4, 1, and P bar is equals to 240, 60, 80, 240, 60, 80, and in the third determinant we will put for T bar, which is equals to OE, which is minus 2, 4, 1, and T bar is equals to 180 minus 180 and 90. Now you can solve this determinant again by using the same procedure. First of all solve for I, then solve for J, and then solve for K. If you solve for I, you will get 7 into 60 is 420, minus minus is plus, so again minus 120, 4 into 80 is 320, this will be minus 60, 4 into 90 360, and this is plus 180. Now we'll start for minus J, so 3 into 60 is 180, minus is plus 40, minus 6 into 80 is minus 480, 1 into 240 is minus 240, minus 2 into 90 is minus 190, 1 into 180 is minus 180. Finally we'll solve for K. 3 into minus 120 is minus 360, 7 into 40 is minus 280, minus 6 into 60 is minus 360, 4 into 240 is minus 960, minus 2 into this is plus 360, and this equal to 720. If you solve this value, your answer is 1100I plus 860J minus 2320K. So our system is reduced to one force whose value is 460I minus 240J plus 230K, and one moment is equal to 1100I plus 860J minus 2320. So if any system is given, we can reduce the system using two equations. One is simply R bar equals to sum of all forces, and second is sum of moment of all forces due to all forces plus C1 plus C2 plus C3 if they are present in our system. Now once we have a knowledge of reduction of a force system into single force, that system can be further reduced into one force and one couple, and that is called as range. So range is normally defined as a force and collinear couple. What is collinear couple? Means the couple is acting in the same direction of force. So we have a one force F bar, we have one couple C bar F, and their direction is same. This together is called as range. Example is our screwdriver, that is a range example, or tightening a bolt or loosening a bolt, that is also called as range. So by this time we assume that you have a knowledge to reduce the force system into single force and couple, and we already discussed this one. So we have one force and one couple at origin, that is a single force and couple at origin, and we want to reduce this system into this type of system which consists of one force and one couple. So what we do is that we will resolve this C bar, one acting F bar and one is perpendicular to F bar. So if we use this one, we will get our figure like this. So C bar I have reduced into two components, one is parallel to C bar F and one is perpendicular to C bar N. So I can use here triangle law. Using the triangle law, I can write C bar is equals to Cn bar plus Cf bar. Now in the third figure I will remove the value of C bar because I already considered the two component. Now if you observe this figure, that is this one, this figure is same as this figure. So there is a one extra component is Cn bar, and we want to remove this component Cn bar. But before this, how we obtain the value of C bar F? If you recall here, I have shown C bar like this. So this is basically C bar F is the component of C bar on F bar. Whenever we have a component, we always write a dot product of C bar as it is, or on which we are taking F bar, that should be equals to unit vector. But here I do not want a dot value, I do not want a scalar value, but I want a vector value. Therefore I will multiply it by one more time using this unit vector, because we know that the vector is equal to scalar multiplied by unit vector. So use this step number 1, this is step number 2, and then we will try to cancel the value of Cn bar. So this is our common step number 1. This one is our step number 2 obtained from this one, which is Cn bar is equal to C bar minus Cf bar. I am interested in this system of F bar and Cf bar. Somehow I want to cancel C bar n. So what I do is that to cancel the value of C bar n, I have a knowledge that whenever I shift the force at the new position, then one couple is produced. I will shift this force to the new position such that whatever the couple is produced, that couple will going to cancel this one. So here it is here Cn bar is an additional couple, and it can be cancelled if we shift the force F bar to a new position A. And then we'll use the equation number 3, that is we want to cancel this C bar n by shifting the force. So we have Cn bar equal to OA cross F bar. So using step number 1, 2, 3, we can successfully develop a range, and finally our Cn bar will get cancelled and this force is shifted to the new position, but we still left with one force and one couple. This couple can be shifted from origin to the new position because couple is a free vector, so we can shift the couple anywhere. Whatever we get now is consist of one force and one collinear couple, and this is called as range, and this range is passing through point A. So whenever you are asked to find a range, then you first check whether your system is at origin or not. If system is not origin, see the first part of this video and then reduce the system to one force and one couple passing through point O, and then follow the step number 1, step number 2 and step number 3. If your point A is given in xy plane, then the z coordinate is 0. If the point in the xz plane, then y coordinate will be 0, and if the point in the yz plane, then x coordinate will be equals to 0. Let's take one example based on this one. So this is a note. Before, you have to check every time that your system has one force and one couple. If not, then follow the step number A and B as we have discussed in the part 1 of the video. So here is the example. I have one force F bar 20I minus 30J plus 10K, and one couple is C bar 56I plus 42J minus 28K are acting at origin. So they are already given at origin. So we have to just follow the 3 steps. Find the coordinate of a point A in xz plane. So y coordinate will be 0, through which the range is passed. So we'll use the standard 3 steps. The first step is C bar F equal to C bar dot unit vector F, again multiplied by unit vector. So this one is a scalar multiplied by unit vector equals to vector. Second, we apply the triangle law, that is Cn bar is equals to C bar minus Cf bar, and finally we'll cancel Cn bar by shifting the force to the new position A in xz plane. So Cn bar equal to OA cross F bar. So I will follow the step number 1. Collinear couple C bar F equal to C bar dot unit vector F dot unit vector F. C bar is given as 56I plus 42J minus 28K. Unit vector can be written as vector upon the magnitude, that equals to 20I minus 30J plus 10K divided by mod of 20 square plus 30 square plus 10 square, and the same term I have repeated here because there are 2 times here. First you have to calculate the inner bracket, then you have to multiply the outer bracket. So we know that I dot I is 1, so 56 into 20 is 1120, 42 minus 30 is minus 1260, minus 20 into 10 is minus 280. This one is root of 1400 and this one is also root of 1400. So root 1400 and root 1400 will become 1400, and this term will be as it is. Now we'll solve this first, and what we get is minus 0.3 multiplied by 20I minus 30J plus 10K. So we'll multiply this inside and we'll get minus 6I minus plus 9J minus 3K. So this is a demonstration of step number 1. So write this first, then solve the inner bracket and then solve the equation to get the value of C bar F. Now we'll perform the step number 2, where Cn bar is given by C bar minus Cf bar. So we'll substitute for C bar. C bar is given as 56I 42J minus 28K, and C bar is this value. If you perform this calculation, you will get C bar n equals to 56 minus plus 6 is 62, 42 minus 9 is 33, minus 28 plus 3 is minus 25. And finally we'll go for the Cn, where point A is in the xz plane. So we'll select the point A in the xz plane, and this point A in xz plane, so its coordinate is x0, z. Now let's solve this equation here. So we'll get Cn bar equals to OA cross F bar. So this can be solved using a determinant ijk. OA has a coordinate of x0, z, other point is origin, so itself a coordinate of given point A. And F bar, we know F bar is equal to 20I minus 30 plus 10. Now we'll equate this, and for this we'll substitute this value, that is 62I, and then finally we'll compare with the coefficient of ijk. So if you solve this, you will get this equation, and now you can compare the value of ijk to solve for z value and then x value. So here I equal to 62 and here I equal to 30z, so z equals to 2.067, and here k equal to minus 25 and k equal to minus 30x. The middle equation, that is this equation, you can use for cross check. So you can substitute x equal to 0.833, z equal to this, and check, you are getting 33. Almost 100 times you will get the same thing. And finally your coordinate of the point A will be equals to 0.833 2.067. So this is how you have to process the step number 1, step number 2, and step number 3. Now this problem is slightly different than the previous problem. In the previous problem we have given the force passing through origin, and this time we have given the force F of magnitude equal to 30 Newton passing through point A, whose coordinate is 4, no change in y, so y is 0 and z equal to +2, and point B is lying on the y-axis, so coordinate of point B is 0, 4, 0, and we have one moment given as 72J plus 36K. We want to find out the coordinate of the point C in xz plane where the range is formed. To this, first you have to reduce our system to a single force and single couple passing through origin. So that was the first basic condition, because the force is not passing through origin. Our steps are only defined whenever the force is passing through the origin. So for this we will perform the two steps. First step we will find out the resultant force, but we have only one force, so that is itself is the resultant. So we will simply find out F bar, which is equals to F AB bar upon mod of AB bar. F value is 30 and AB bar is coordinate of B minus A, so you can substitute and you can solve this equation. The denominator will be equals to 6, 4 square plus 4 square, 16, 32 plus 4, 36, root of 36 is 6, 30 by 6 is 5. So our force will be given by the F bar equal to minus 20I plus 20J minus 10K. And then we'll find out the sum of moments about the point O. So we have one force and we have one couple. So there are two terms here. One is due to the moment due to the force and one is couple. That can be obtained using the OA cross F bar plus M bar. OA cross F bar can be obtained using a determinant. So we have a determinant of IJK. Coordinate of A itself is equal to OA, that equals to 402, and F bar is equals to, we have just find out, minus 20, 20 and minus 10, and M bar is equals to 0I plus 72J plus 36K. Now we will solve this determinant, and if I solve this I will get this result. I will add it and my final value of moment will be equals to minus 40I plus 72J plus 116. So we are using these two steps, we have effectively reduced the force and couple system to the origin, and therefore we can write the value of C bar is equal to sum of moment of forces about point O, that equal to minus 40I plus 72J plus 116. And now I will show the system, the reduced system. So I have one force and one couple, and the value of this force we already find out is minus 20I plus 20J minus 10K, and couple is equal to minus 40I plus 72J plus 116. Now after this you have to perform the three standard steps, and the three standard steps will be, first is C bar F, then Cn bar, and then Cn bar is to be cancelled by shifting the force to the new position. So let's perform the first step, that is Cf bar. So this equal to C bar, which is equals to this value 40I 72J 116, and then we have to write down the force vector, unit force vector. So F bar is equal to minus 20I 20J minus 10K, and the modulus will be equals to under root of 20 square plus 20 square plus 10 square, which is equals to 400 plus 400 plus 100, 800, 900, so 30. And now we'll solve this, and if you solve this one you will get minus 40 into minus 20 is plus 800, 72 into 20 is plus 1400, 1440, 116 into minus 10 is minus 116, this one is 30 and this one is 30, that equal to 900, and this stuff I have written here. Now we'll solve this, and if you solve this one you will get 1.2 multiplied by this term. After expansion you will get C bar F equals to minus 24I plus 24J minus 12K. Now we'll perform the step number 2, that is Cn bar equal to C bar minus Cf bar. So we'll substitute for C bar. C bar we obtained as minus 40I plus 72J plus 116K, and C bar F we have just obtained, that equal to minus 24 plus 24J minus 12K. And now solve the value of Cn bar. So if you solve Cn bar you will get minus 16I plus 48J plus 128K. Now we will perform the step number 3. So we will shift this point force to somewhere else so that it will develop one couple, and that is going to cancel this one. So if we cancel this one, then we have the point A required, or rather we required a point C. So you treat this point equal to C point, not as A point, or you forget about this figure and let's check the another figure is a fresh figure having coordinate equal to x0 z. So we have Cn bar is equals to OA cross F bar. So we have OA cross F bar is coordinate of A is x0 z and F bar is minus 20, 20 and minus 10. Now substitute for value of Cn bar that we have just obtained as minus 60i plus 48i plus 128k, and solve this determinant for ijk. Now compare the easiest coefficient that you can calculate. So first of all I will compare the value of I, and if I compare I will get minus 16i minus 20z, so z equals to 0.8. Then I will compare the value of k, so I get 128 and this equal to 20x, so x equal to 6.4, and therefore my coordinate of point A will be 6.40 because it is in the xz plane and the z coordinate is 0.8. So these are the two examples on the range. First one is a straightforward where the system is at origin. Second one is little bit complicated and we have performed 5 steps here. First we have reduced the system to a single force, and once we have reduced the single force passing through origin, we have performed the 3 standard steps which are required for the range. Thank you.